it when people complain, oh, class goes so fast for me. Do you watch videos? No. I'm too busy watching cat videos and kids falling off fences and stabbing themselves in the balls. Good use of the internet time. I have the entirety of math, of human knowledge at my fingertips, but I only know that I'm surprised at what this celebrity looks like now, 20 years later. I don't click clickbait.
But the results will show.
Mm-hmm. Anyways, there was a lot of issue in my other class about why... Oh, shoot. Excuse me a moment. My highlighty circle is gone. I like my highlighty circle. I would like it back. It's still not back. Highlighty circle. There you are. See, the highlighty circle is nice. You guys all mock me for it, but it's very helpful, isn't it? Just say yes. There we go. All right. A lot of talk in the other classes because everybody's starting with exponents regardless of level. Why this stays negative a when it's negative and a negative. Locke? I haven't actually done anything with it, right? The base is negative. Now, you got to leave it that way because you don't know what a is. Is everybody good with the first 8 that you can see on the screen? Once, twice, thrice. Lovely. And there's the next, I think it's 11. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, it's 9. 2, 3, 4, 5, 6, 7, 8, 9. Everybody good with them? Check your work. If you would like to see one, holler the number and the letter.
Is K 1x6?
K. Yes. Everyone is Gouda? Great. Whoa. Oh, I didn't do I. Fine, pushy.
Can you do 8?
Can I do 8?
A.
8A? Yes, I can do 8A. Of course I can do 8A. I'm the math teacher. Would you like to choose the color?
Yes. Blue.
Blue? Light blue, dark blue, aqua?
Dark
Dark blue, dark blue, dark blue.
That's good.
So, the way to think about this, of course, is remember that I've made numerous mention of the fact that you can't forget all your other math, right? So we've started this year with exponents, but that first thing is 7 times 5, right? So that's the 35. Ooh, I hear a seagull. 35. And then a to the 4th and a to the negative 1. If you only know the laws, that's 4 plus negative 1, which is 3. A cubed. B squared. 3 plus 2 is b to the 5th. And that's it. No problemo. I didn't do I, so I will quickly do I right here. That is e squared f to the 4th over g to the 10th. Yes, that's a g. An 8? Okay, well, it's a G. Come on, you people know how to read math. If it was a number, it would be at the front where coefficients live, right? No, dude, because this isn't for marks. It's just for you. Shayla, hit me.
Why is f to the 4th?
F. Oh, sorry, 14th. Thank you. 14th. Everyone is good? Charlotte.
Can you go for 9B, because I got 1 over 6A.
Sure. Again, 4 times 12 divided by 8. 4 times 12 is 48. Divided by 8 is 6, yeah? Negative 7 plus negative 5 is negative 12, yeah? Negative 12 minus 4 is negative 8, yeah? So it's a to the negative 8. So it's 6 over a to the 8th. What did I have? Okay. Because the negative has to go to the denominator. Now, the other way to look at this is the way that you should be looking at this, and that is this. 4a to the negative 7 times 12a to the negative 5 over 8a to the negative 4. And then, of course, you could move all the negatives, or you could just be canceling. Either way, you win. And we will turn the page over to the tough stuff. Now, you will notice there's a crap ton of work on this page because various classes have asked for various kinds of work to be done. But everything in yellow, dressed in yellow, she says hello. If you don't know that song, it's Bust a Move. You should know that song. It's a great song. Yes, it is Young MC.
Have you heard of, what's it called? I Got No How?
No.
That's another good one.
When I was a kid, you couldn't get your hands on other songs by artists unless they were on the radio or you bought the album. I was not going to buy the Young MC album for Bust a Move. And I heard no other songs from it. Now, of course, you have iTunes, Spotify, Google. You can test all the music before you decide to buy, but of course, none of you buy. Right. Why would you? There's no need to buy, which is why poor musicians have to go on tour again. Darn, they actually have to work. Because, I would like to still be paid for something I wrote 30 years ago. I think that kids that graduated from my class 25 years ago should all still be paying me a little bit, which is, of course, horse crap. But for some reason, musicians feel that is how it should be.
Well, I mean, if you count the 5 cents or whatever.
5 cents adds up, man.
Taxes.
5 cents adds up. All right. There, everything is in yellow. Do I need to go over any of them? No? Oh, Benji? 12D, as in doorknob. Excellent. Anything else? Anything before 12D? Okay. So, I'm going to erase all this, and I'm going to color code, because that makes it easier, I think. All right, so, remember, I've said it before and I will say it again. You can't forget all of your other math, right? Is there a bunch of math to do in D? This is a yes or no question. Yes, there's a bunch of math to do in D. Is there a way that we know an order in which we must do math? Yes, that order is the order of operations. You know it as BEDMAS or PEMDAS. The first thing on there is brackets. There is no brackets here. These are not the brackets of which PEMDAS or BEDMAS refers to, because there are no operations inside those brackets, right? So then we must go to exponents. And we notice this 3 right here applies to this whole base, yes? So I must do that first. Now, the way to make sure you succeed in math from here until the end of your mathematical career is never to ask the following question. You'll have to show work. Never, ever ask it. You've been asking it since the very first math class of the very first day you ever had math. And your teacher has always said what? Yes. And yet you people continue to ask. I don't know why you think the answer is suddenly going to change. As the math gets more and more complicated, all of a sudden, no, just go ahead, write down whatever the hell you want. You have to show work. So I'm not doing any work with the first one, so it is staying as negative 5, x to the 4th, y to the 5th. Now I'm going to keep my color coding going. The yellow is right there, and it is 2 to the 3rd. What is that? 8. 2 times 2 times 2. X to the 3rd, x cubed. Y squared cubed is y squared, y squared, y squared, which is y to the 6th. Yes? Then I look down at the bottom and I see another exponent applied to a whole base. So I must do that. Oops. And I will highlight to keep the color coding going. 10 squared, 100. X cubed squared, x to the 6th. And y to the 8th squared, y to the 16th. Yeah? Now, still, I have BEDMAS to deal with. I must deal with this entire box up here. So, I will deal with my x's, which I will highlight green. I will deal with my y's, which I will highlight pink. And I will deal with my coefficients, which I will circle in red. Negative 5 times 8 is negative 40. X's, 4 and 3, x to the 7th. And 5 and 6, y to the 11th. Any problems? Of course not. Over 100 x6, y16. Now, again, if you're just memorizing laws, you will get through it, but you will find yourself confuzzled. Learn what's really going on. There is negative 40 divided by 100 is negative 2/5, right? 7 x's up top, which means if I write out, there'd be 7 x's there and 6 x's on the bottom. What happens? It just goes to x, because these 6 disappear, 6 of them disappear, x. What happens here? There's 11 up there and 16 down there. So those 11 are going to disappear, and that is going to be y to the 5. It's already on the bottom, right? If you're going to go by laws, that's y11 minus 16, which is y to the negative 5th. If you're only going by laws, you have to assume that everything is going to be in the numerator, and then you must move appropriately afterwards. That's why I don't like going by laws. I like knowing math. Everybody cool? Yeah, ease bees lemon squeezy? Yeah? Yeah? Okay. If we are all good, we can move on. Are we all good? Jay, I'm sorry, what? That was 12D. So, let's discuss that. How? What do you have?
1 over negative 1.
1 over
Negative 1, x to the power of negative 1, and then y to the power of negative 1.
Okay. So you, of course, showed your work, yes?
Yeah.
So you should be able to follow what I did, yes? Do you agree with what I did? Pardon me? Please do so. That's cool. 5 times 2. Okay. I don't see where that would have come up, but all right. Ah, I see. You forgot that 2 was cubed as well. That'll happen. All right. So we're all good? Yeah? Okay. Let's move on then, cabbages. You see the very next thing here. What's that say? Quiz 1. When could that happen? Anytime after I finish this sentence. I'm going to keep speaking as long as I possibly have breath before I put a period in this sentence, and I'm not going to pause for a comma or a semicolon or anything like that. So quiz now. Just kidding. It's not worth anything anyway, but you would still be stressed. You would. You might. So your next page should be really hard exponent practice, yes? Yeah? Okay. That's your homework tonight. No. It's what we do in class. We're going to move on to page 21, it should say. Yeah. Now, you will notice page 20 has the answers to the really hard exponent questions. Wait a minute. Why would he ever do that? The same reason textbooks put the answers in the back. So you can check your work, because being past millennials, you need the instant gratification. You will do the one question, you will flip to the answers. Right? Don't tell me you won't. You're liars. It's okay. Yeah, all of you shamefacedly, or you're doing that thing that kids do now. He's not wrong, which is code for he's right. But you don't want to say that the person's right, because then it looks like you're sucking up. So if you say he's not wrong, you can still maintain some plausible deniability. That's beside the point.
Mr. Myers, that is wrong. I guarantee you a solid portion will take these answers and then work backwards.
Oh, I know they'll do that too. That, of course, goes without saying. Yes, reverse engineering is, of course, a move that you are all good or quite comfortable with. So you're going to work on those, 8 questions, 12 questions? I don't know. 10. And, of course, I won't do the quiz until we've gone over those really hard exponent questions.
So those are going to be on the quiz too?
What do you mean?
The
Questions
harder
of that caliber?
Yeah.
Yes, of course they would be. Because you practice the way you're going to play the game, right, Mia? If you don't practice the way you're going to play the game, what the hell is the point of practice? When you go to swim practice, do you swim slow?
Not really,
Exactly. Why?
because we need to get better.
Because you need to, at the meet, you need to kick ass, right? The competition should be easier than practice. Because if the competition is easier than practice, then you kick its ass. And yet, that's not the way we ever do anything. People skip practice, they dog practice, right? But whatever.
Why don't we just practice for twice the effort and then it's going to be easy?
It's exactly what I just said, Gideon. Like word for word, what I just said.
Give us,
Thanks for your endorsement, though, buddy. That's key.
why don't you give us grade 11 questions? So we'll be real in practice. So we'll just destroy all grade.
I guarantee you my grade 11s could not do that really hard exponent questions right now.
Really?
So don't worry about it. Moving along to page 21. You already know this whole page too. It's review. Why am I reviewing it? Because... No. I'm reviewing it because what we're about to go into requires a refresher on how to multiply polynomials. Because we're about to start multiplying numerous terms of radicals and numerous exponents. So we will review polynomial multiplication. And of course, you will notice the very next unit is entitled Polynomials. So I'd like to make sure we are all on a grade 9 footing for polynomials. Okay? I know some of you won't need it. That's all right. Okay, let's go on. A polynomial is... What's a polynomial? Who knows? Ethan, hit me.
It's an equation of multiples.
No equation. Charlotte. An expression. An expression. Now, carry on, Charlotte.
With multiple, integers?
With
Numerals?
terms. That's what I like to hear. An expression with a combination, and I'm lazy, so I'm writing combo, of variables and constants. Now, variables have a little thing that might stick off the side of them. That's a coefficient. And you all remember what a coefficient and everything is. I will remind you by writing out a polynomial right now. X. That's a polynomial. Why? Because it's a variable. Excellent. Variable, variable. 3x. That's polynomial. Why? Because it has a coefficient. Look at this guy. Plus 7. Is that a polynomial? Yes. Why? Because it's got a constant. 7 is always 7. Everybody cool? Now there's some rules to this. All right? This is one rule. This is a polynomial. Check. These are not. 1 over t squared. That is not a polynomial. Can't have an exponent in the denominator. All right? This is not a polynomial. 3 to the x. Not a polynomial. Your exponents can't be variable. Everybody cool? All right. You all understand how English works, most of you. Mono means what? One, right? So a monomial is an expression with one of those things. One of those. These are called terms. Now, being the bright young minds that you are, you of course know a binomial must have two. Is an expression with two terms. How do you know a term has ended and a new term has begun? Aditi. Right. There needs to be add or subtract between the terms. So, you don't need to write this down. 3x. Is that a monomial? Or a binomial? Monomial. Why? There's no addition. That's multiplying. Okay? X over 5. Monomial. Why? No addition. Mono or bi? Binomial. Excellent. Yay. And of course, a trinomial is an expression with 3 terms. I'm so lazy, it's appalling. Now, you are all aware of the fact already that if I leave you a lot of white space, it's an important topic, yes? Okay. How much white space have I left for the degree of polynomials? Almost none. It is unimportant. But when I show it to you, it's going to confuse some of you, and you're going to actually spend brain power trying to figure it out. Don't. Okay? Okay. The degree of polynomials is simply the sum. How do you find a sum? Pardon me? What operation finds you a sum? Addition. Right. The sum of, I always forget this word, the highest sum. And I should have said greatest. I know. Don't give me any of that crap. The highest sum of the exponents. And I'm going to highlight the word exponents in any one term. Okay? So, I'm going to write a red polynomial here. I want you to tell me its degree. X squared. What degree is that? 2. Why? Because that's the only term and it's got an exponent of 2. Well done. 4. 0. No exponents. Highest exponents. I forgot that too. Of variables. Because 4 is only 4, right? It can't change. It's a constant. X, y plus 2x. This definition is right now. The highest sum of the exponents of the variables in any one term. So what's my first term here? X is a term? XY is a term. What's my second term here? 2x. So, it's 2. Because x and y are 1 and 1, so it's 2. Good? 3xy squared plus 4xyz plus 3xyz squared. 4. Why? xyz squared. 1, 1, 2. I'm done with degree. The only reason we do it is we like to write in descending degree or descending exponents of x. So what that means is if in your polynomial you have an x anywhere, you put that x first with the highest exponent first. And as of now, I want you to put that out of your head. Because if you think I'm going to take away credit from you because you forget the way you write stuff down, you're in the wrong room. All right? If you remember, do it. If you don't, don't. I just have to show it to you. Because it's one of those things that some math person somewhere said, kids should really know the degree of polynomials. Okay. Everybody good? Promptly put it out of your head. Now, we are not going to break out algebra tiles, but we are going to draw them. Which of those is actually 1? Is it the black box or is it the red number 1? Roy. Okay. Neither one of those is actually 1. That's Roy's contention. Does anybody wish to refute that or concur with that statement? Ethan.
I choose to lightly argue it by saying that you did mention is the white box or the 1 the actual number, the 1 would be the 1, I think.
Okay. The 1 is a 1. You're absolutely right. Okay.
And now I strongly argue it. Now that I know it's backed up.
Now, which of those things is actually a single thing? The square. Everybody understand? What do I mean by that? If I write this, how many numbers did I write? I wrote 1 number. But how many things does that symbol represent? 2. Numbers are symbols we use to represent other things. All right? So if I want to do something concretely, I have to use actual things. And I don't like them, but some math person invented algebra tiles, which are real useful if you never go above an exponent of 2. Unfortunately, there's a lot of exponents past 2. But again, we have to show them to you. So, it is decided that an unshaded box is a 1, a shaded box is a negative 1. Or change it. I don't care. There are some modern textbooks that don't wish to get into the black is negative and white is positive argument, and they color them like red and yellow. Because people make a choice to see inherent things like racism in places where it isn't actually there. Of course, one day aliens may come down and they may be red and yellow and they may live with us like in District 9, and then maybe we won't be able to use red and yellow either, or purple and chartreuse. I don't know.
Oh, the goddamn those chartreuse aliens stealing our jobs. We need to build a wall around the earth. A Dyson sphere
No, actually, what's really going to happen is they will build a Dyson sphere around the Earth, but the aliens will build it to keep us here. So they can quarantine this horrible planet and not let it get out and ruin other planets. It's actually the rest of the aliens in the universe that want to keep us here. All right, so that's one. Now, the next one is this. It's a bar. Now, this bar is not an exact measurement of these. 1, 2, 3, 4, 5, and a bit. Since it's not exact, do you know its value? So what is it? X. Good. And this is negative x. And then we have these big ones, which is this stretched out. It is, oops, that was a crap-ass drawing. That, but it is stretched out. That should have stayed square. Anyways, that is x squared. All right? And I'm going to show this to you 3 more times. I'm going to make you do it 2 times, and then we're never going to use these again. All right? Ever. Because I hate them. And kids that can do math and can't work with these things think they can't do math anymore, which is dumb. But I am not in charge. So, Lala.
Isn't there also an x cubed when you actually draw a real cube?
Yeah, there is, but come on. No! Oh, it's DeVries. All right. So, what in English, read that mathematical sentence to me. That's very precise. I would have gone with 5 times x plus 1. But that's just me. Everybody agrees, yes? Okay. So, if we were to draw x plus 1, there's an x, there's a 1, yes? How many times do we need to draw it? 5 times. Agreed? Could I have drawn it another way? I could have, yes? But the point where this will become useful in the very near future is when you make them into a rectangle. And of course, you see on the sides of the rectangle, that edge, 1, 2, 3, 4, 5, and up here, x and 1. And you see that you get a product in the middle, and you get factors on the outside. And that is going to become very useful very soon. But for right now, it is key that you can take this math sentence and make it into something real. Everybody cool? Good. Now, of course, this is what we are going to do. Algebra. 5 times x plus 1. And you already know how to do this. What does that mean? That means 5 times x plus 5 times 1, which gets you 5x plus 5. Now, you have all been shown this shortcut, boom, and boom, and your teacher probably had a fun little name for it. I don't care what the fun little name is, because it's not the real name for it. What that is the distributive property. I'm not even going to say all the other names that I've heard for that, because they all drive me batty. Just like I wouldn't want you to call me Mr. Jones, because that's not my name. Okay? Just like I won't call you Jennifer if your name is Aditi. I will call you by your name. That's what we do here. Yes?
I don't think I've ever heard another name for distributive property.
Good. I'm glad. That means my hatred and my war against stupid names for math concepts is winning. The distributive property says simply this. A times x plus a times y. How long will that continue? How long will this distributive property continue? How many times will I have to do this? Jayden? As many times as a is worth? Kinda. Because if a is worth 2, I'm going to make 2 of them here, right? But it's not how much a is worth, it's how many terms are in there. Because I need to multiply by x and y. If I add a z there, then what's going here? AZ. If I add a q there, what's going here? I forgot the A. AQ. And so on and so on and so on. Every time you multiply, you need a new term. Right? You already know this. So, draw this for me as a picture and in algebra. Obviously, the algebra one is way easier. You can do that in your sleep, right? So, I don't care which one you start with, but do them both. Go. It should take like 10 seconds. If you finish that one, do the bottom one. And everybody should easily have been able to do these monomial times a binomial. Yes? Like this is grade whatever. I mean, really, you probably didn't see it until grade 6, 7, or 8. But really, we're doing grade 3 math, aren't we? Because we're just multiplying single things, right? Okay. Turn the page over. This is different. Because what do I have here? I have binomials, yes? And you, of course, all already know how to do this, but I'm going to make you do it because I've got to make you do it. X, 1, 2, 3. That's one factor. Here's the second factor because it's two numbers multiplying together. X, 1, 2. X squared and your answer lives in the rectangle. X squared plus 5x plus 6. Right? Now, algebraically, I have x plus 3 and I have x plus 2. Now, you all already know this, but again, I like you to see why. If this wasn't there, what do you have? Lock.
X squared plus 2x.
Plus 2x. X squared plus 2x. X squared plus 2x, yes? If this wasn't there, what do you have? Lock again, hit me.
3x plus 6.
3x plus 6. Right there. Right? Easy peasy lemon squeezy. What must I remember to do every time that occurs? Lock again. Finish us off. Simplify by collecting the like terms. Right? Now, that leads us to what you all, I am sure, have heard described as FOIL. Yes? FOIL is an acronym. How do I feel about those? I don't like them because it only works if it's binomial. Are there polynomials bigger than binomial times binomial? Yes. And yet we spend so much time FOIL, which works for one situation. The concept works for every situation, right? So I'm going to spend 1 second talking about FOIL, then I'm going to explain what you really should take away from it. FOIL stands for, I'm going to write it out, x plus a and x plus b. FOIL stands for first. So what you do is you take the first term you see and you multiply it by the next first term you see to get x squared. O stands for outside, which means you take the outside term and you multiply it by the outside term, which will get you plus bx, right? I stands for inside, which means the two inside terms, which will get you plus ax. And L stands for last, which is the last two, which gets you a times b.
Why would anyone need an acronym for that? You just multiply it.
I know that. It's just double distribution. Once you see the distributive property once, you shouldn't need that acronym. And yet. So, now you should see that I have some x's there and some x's there, yes? So what I like to do when I have to do this by hand, I don't like to write it horizontally. I like to stack it vertically. Because then my x's are lined up and easy to add. Now, if it's only a binomial times a binomial, then you've only got one set of like terms, yes? But as the polynomials get bigger and bigger, you're going to have more and more sets of like terms. And if you stack them, I personally have found it makes simplification easier. Do you have to do that? Of course not. So, right there, we're going to do this because it's a super easy one. We're not going to draw it. We're going to double distribute. We're going to start with the first one and get x squared plus 4x, right? Then we're going to go to the second one, and we're going to have negative x minus 4. And because I've kept my x's together, it makes it really easy to collect my like terms. X squared, 4 minus 1 is 3x. 0 minus 4 is negative 4. Yeah? Yeah. Everybody good? Now, I'm going to give you your first gift that you probably already know. What do you notice about the relationship between 2 and 3 in my question and 5 and 6 in my answer? You can see no relationship between 2 and 3 and 5 and 2 and 3 and 6. Shayla, give me one part of the relationship. 2 plus 3 got me 5. What's the other part of the relationship? Rachel. 2 times 3 gets me 6, right? Okay, look at this next one. What is the relationship between negative 1 and 4 and 3 and negative 4? Roman. Adding and multiplying. If something happens once in math, how often does it happen? Every single time. That's why math is so awesome. There's no OUGHs in math. If there is no leading coefficient, that trick will work. You simply add these to get b. You add them to get b, and then you multiply them to get that spot. Always. If there's a single letter. I don't show you that first because it only works if there's no coefficient here. That's why I make you do all the other work first. But now that you can do all that work and you can do it in your sleep because you're all the best and brightest, now you can have the shortcut. Some of you must have known that already. Good. Okay. I would like for you, for the rest of this class, it is your choice. 24 and 25 I want done for tomorrow. You have 25 minutes left in class. You may work on 19 and 20, which was a really hard exponent practice. Or you can do this. Or, if you're really efficient, you get it all done and have nothing to take home tonight. Is it possible I have an exponent quiz for you tomorrow? Yes. It is possible. Everybody understand? Is that quiz anything to be bothered by? No, because of course I make you practice harder than the game. So if you can do everything we've done with exponents already, you're already going to destroy the quiz. If you maintain that ability, you are going to destroy the tests. Clear? Go. Holy Lala. I know you're excited, but come on, man. Take your eye out with those things. I am going to take attendance and then start walking around to offer help to people that say they don't need it. Okay? And what will really happen is I'll do 2 laps of the class, nobody will want any help, and then somebody will say something that interests me, and then we'll have a talk about something that isn't math. Okay? Go.